I'm here between you and your lunch, so I will try to make it as quick as possible, but at the same time, my duty is to make you forget about your lunch for the next half an hour. So let's see how it goes. There are times when you're working on your code base, like the chap here, and it's Friday afternoon, you're happily hacking at whatever you're doing, but suddenly there's a little bug showing up somewhere in the code, and you're like, oops, there might be a bug, and your coworkers, which you can see here, but just pretend you're seeing Frodo, are like, don't look at the bug, but the bug shows up and attacks you, and then you make faces at the bug, and the bug makes faces at you, and then you eventually vanquish it. And if it's a typical bug, then you vanquish it and it's okay. If it's a Jesus bug, which you think you have it nailed down pretty well and it comes back to haunt you 3 days later, then this is basically you on Monday, but the upside is you have all those very nice stories to tell afterwards from the trenches. And just think for a second, how different could it be if Gandalf had better tooling? If he were a better engineer, if he actually knew his tools, would this be what he tells to our fellowship and everybody else? I'm Piotr. I work at the university. I'm the CSO at the Warsaw-based Ruby and Rails consultancy. If you want us to work for you, get in touch with me. And this talk is based on a couple of assumptions. You know there are nifty things you can do with tools. You've seen some blog posts that describe them in excruciating detail, and you can't remember 90% of what the blogs were about, including that one trick that you really wanted to remember. So it would be cool if somebody just limited this to all the tricks that are actually useful and are maybe not necessarily very widely known. We'll cover Git. We'll cover a tiny bit of PostgreSQL. Obviously, this is what we have to cover. And actually, we'll also cover some command line tooling and some basic piping between tooling. Let's start with Git. Git is this wonderful thing that we use. We know that it looks like a sharp knife, and the handle is also a knife, and each side contains more knives fractally. But then you learn more about Git, and you have all of those visions like how branches work, and you eventually realize that they are homomorphic endofunctors mapping submanifolds of a Hilbert space, and everything just fits into place. And the nice things about Git is you can play very nice games with your team by using Git. You can create a remote branch called head and see what happens, especially close to a release that's actually very nice. You can use Unicode names because these are just files on the disk. And the things that actually are very nice about Git is that you can alter the commits and history. Git commit amend, which can also be abbreviated, apparently. It's something that you can use very often to update the previous commit that you just made. But this is actually the text. I'll read it for those in the back. Just discovered Git rebase interactive auto squash. Holy shit, we'll never again need to do any work. That was actually the tweet that prompted me to give this talk, because I didn't know about Git rebase interactive auto squash, and I'm really happy that I know now. So hopefully you will also know about it in a second. Let's start with a simple Git repository. And let's start with creating an empty commit. This is something you don't usually do, but if you ever had this nagging thought that maybe you really, really need to rewrite that project, which probably you have had many times. I have it about every other day, and I rewrite my pet projects about every quarter. This allows you to create an empty commit at the root of your repo, so you can then branch off of this commit without it having any files. So if you want to rewrite your application in a different programming language, you can actually rewrite it in the same repo and just switch the master at some point for all the fun for your users, while this being the same repo. So let's say we have this commit. It has a very nice SHA, because we're very lucky. It's Looks like it tries to spell ageless but can't. And let's say we have a README because we are of the README-driven development cult. And let's add this file, let's commit it. Again, we are lucky to have the cabbage SHA of the commit. And let's start coding. We are working on an application to take over the world, so obviously this is the first implementation. And let's also add this, commit it with a code foo hash, and let's review what we have so far. The git log on one line decorate is a very, very nice thing to have, for example, aliased, because it gives you a log with just the SHA and the commit message, and if there are any branches pointing at this commit, it also spells them. There are a lot of blog posts that say what you can pass to this command to make it all colorful, but if you want to just use it, the quickest way is just to do this. And by the way, if you're into colorful slides, unfortunately, there won't be any more color in this talk. It's all black on white, pretending it's white on black. So let's fix our README now. We really weren't actually that good at writing the README. We should have it capitalized. And the simplest way to capitalize a file is to use the tr tool, which translates one group of characters into another. So this one translates all lowercase characters into uppercase characters. But if we just run it, it would display it. And if we just pipe it back to README, and the README was long enough, it would corrupt the file, because it would try to read from the file and write to it at the same time. So it would overwrite the file. What people usually do is create a temporary file and then move it over. But what you might find using in the future, now that you know about it, there's a sponge utility, which basically sucks anything that goes into it and outputs it to a file only when it's finished. This is very nice thing to use when you want to alter a file in place. So now we have this, and the trick is we really want this change that we now have to alter this commit, not the newest commit, which we could do with just git commit amend or git commit amen, but we actually want to do this to this commit. So what we can do is we can make the commit message in a very particular format. If the commit message is fix up bang space and then this SHA or just like large enough part of the SHA, like cabbage, to fix it up, then the magic can happen. So this is another commit. It's just like the fourth commit. If we now see the log is ageless, then the cabbage, then the code food, and the seafood. And if we now rebase our branch against the parent of the cabbage, so to speak, then if we do interactive, it will allow us to reorder the commits. But if we do auto squash, it will also understand this fix up comment, and it will provide us with an editor that already have this commit next to the cabbage and mark it as a fix up. If we save it, then the log will look like this. First the ageless, then the cabbage and seafood squashed into bad food, and then the code foo with a new SHA of beagles because it has a different parent now. So git rebase interactive auto squash, very useful. Okay, let's go on. Let's say we have a file that, for example, stores the Ruby version of a program that we use. We add it, we commit it, and then we want to use a different version of Ruby, but only on our laptop. We want the repository to still have the 2.0 version. So we save 2.1. The trick is now we have this file modified in our working copy. Git status short branch is a very nice way of displaying status. It shows you which branch are you on and what are the changed files without all the usual git status craft. This is also something that might be very useful. So now we have the situation where we have a modified file in our working copy, but we don't want to commit that change, and we don't want to be reminded that the change is there all the time, so we have to skip it when committing stuff. We can do git update index assume unchanged, and then that file, and then when we run status, it will show that it's actually not change. And the nice, well, in general, you shouldn't have those kinds of situations where you have a file and repository, a different version of that file in your checkout, in your working copy, and you keep ignoring it. But there are certain edge cases when this is actually useful, like .rvmrc files, some configurations files that shouldn't be in the repository in the first place, but are, and you have a local changes, git update index assume and changes is very useful, and it will actually tell you if there are some updates to that file in the repository that can be merged to your version. So let's go on. Let's create a new branch, Pinky, and let's realize that our world domination application is actually runnable by anyone, whereas we want it to be only runnable by Brain, because he's the one who's supposed to take over the world, and Pinky is not necessarily supposed to take over the world on their own. So let's adjust the plans that if this is run by Brain, then we actually take over the world. Otherwise, we say, well, nice try. The thing is, when we run git diff tells us that we have removed one line and added 5 other lines, which is not necessarily true. We actually indented that single line a bit and wrapped it around in conditional logic, or wrapped it in conditional logic. So what we can do is git diff ignore all space, and it will show us the diff without white space changes. This is very useful if you have a coworker who makes some changes and also re-indents the whole file. This is very useful. Or if you're the nice coworker that re-indents the whole file and makes sure that it's only a re-indenting commit, because, for example, you anticipate this is the file somebody works on, so you, of course, go and re-indent it, add white space, and so forth, so he has more fun, and or she. And then this allows you to display things without white space changes. We can add this, and we have another commit. And now we want to switch back to master. We could do git checkout master, but we can actually go git checkout dash. This is exactly how cd dash in the console that takes you to the previous directory. This actually takes you to the previous branch. So if we run it now, we switch to master. If we run git checkout dash again, it switches us back to Pinky. This is very useful if you work on a branch, then go back to master, then on a branch, then go back to master. Git checkout dash. Okay, so what did we learn about Git so far? We can create empty commits. We can rebase with auto-squashing and make it look like we knew what we were doing all along. We can update index so that it doesn't track files that we don't want it to track. We can do git update index no assume unchanged, which reverts that change. And git diff -w is the shorthand version of ignore all white space. And actually, if you have a GitHub URL that shows you a diff, if you add w equals 1 at the end of the URL, then GitHub will not display white space changes. This is very useful when you're reviewing PRs to just hide the white space changes. Git checkout dash takes you to the previous branch, and one thing that you probably, some of you, maybe most of you, knew all along, if you want to add only some changes that you made to your next commit, you do git add -p, which goes one file after another by adding chunk after chunk or patch after patch that you made. So you can compose a commit that is only from some of the changes that you made. But what I didn't know, and you might not as well, -p also works with git checkout, so we can revert some of the changes but not all, and also with git stash, so you can stash only parts of the changes that you made but not the others. So this is the last thing about Git that I think is worth using on an everyday basis. So let's go further. PostgreSQL. PostgreSQL, this wonderful database that unfortunately is not the most popular relational database. Maybe it could have been if it was named differently. But we can work on that. We can work on the naming of PostgreSQL. And I will do my best to name it like this until the end of this talk. So the actual important thing that you should know about PostgreSQL is this page. If you go to the documentation, if you look at the data types URL for PostgreSQL documentation, you will see all the native types that PostgreSQL supports. And if this doesn't convince you this is the best RDBMS ever, then we need to talk seriously. Okay, let's say we have a database, and let's say we want to track the agenda for this conference. So we can create our own type that is enum of either first track, second track, or both tracks. And we can use it just as in any other PostgreSQL type. So we can create a table that tracks the track, the speaker, the title, then has this column that is range that we will get into in a second, and then it has this interesting text square brackets column. What we can do, we can insert the first item, which is registration, and this range column is a timestamp with time zone range, which means if you want to track things that happen, that have some time spans, for example, or are happening between 2 different years or any kind of range, you can actually track ranges in PostgreSQL. This means that this range includes the 830, and that parentheses means it excludes 9 sharp. So you can actually say whether the range is inclusive or exclusive and on which end. And when we select this, we actually see that indeed this is a range of timestamp with time zone, and the time zone was properly inferred that this is the CET time zone. Okay, let's go further. Let's create another agenda item, and let's also include one more now with the tags. Tags is an array of strings. We can actually have arrays in PostgreSQL columns, and the syntax is kind of strange, but your favorite PostgreSQL adapter in your favorite programming language will take care of that. And the nice thing is that we can, again, create entries that are arrays of whatever you want, like numbers, times, any PostgreSQL type. And now when we select it, we can see that those two talks are tagged with C# mobile, the first one, and the second with CSS and color. And this is actually very, very useful because you don't need a separate tags table, and you don't need a separate join table. You can actually index this column, and the searches will work fairly well. So let's insert a couple more talks. And what the ranges allow us is that we can actually ask the range for its lower bound, and of course this will give us a timestamp, so we can cast it to car and say we only are interested in an hour and a minute, and we can have a very nice agenda of all the talks that we have seen so far. And again, because the time is a range, we can ask what were the talks that were happening at 9:45, and this is talks where time included this thing. Again, the syntax is kind of bumpy, but your library will take care of that. Ruby, Python, other languages for sure have libraries that take care of this. So we can say, right, these two talks were happening at 9:45. And just as well, we can say, what are the talks that are tagged either with AngularJS or JavaScript? Again, the syntax is kind of not necessarily very intuitive, but basically we say where AngularJS is in any of the tags or JavaScript is any of the tags. And again, we can see that so far these two talks were about JavaScript and AngularJS. So PostgreSQL, custom types, ranges, arrays, search. You can create wonderful time vector searches, HStore, which is key value store, JSON and geometry types, and PostGIS and XML. You can index XML and query it, and you can work with Mac IPv4 and IPv6 addresses, and UUID is supported natively, and so on and so forth. This really, PostgreSQL is really, really the hacker's database. Please play with it when you have time. There is quite often, there is not much need for use other databases other than being a different kind of, they have properties like being in memory or anything like this. Okay, the last part, CLI. There are tons of commands useful on an everyday basis. This will be just some of them, and some pipe chaining, because some of you probably use it on an everyday basis, some of you might not. This is actually very easy unless you do this, what mistype find awk exarchs aram pipeline backfires killing Tedjuba. Tedjuba wrote a lot of stuff on CLI, so that actually might have been the reason. Okay, let's say we want to look at some files in our repository, in this case, Rails models. Find will display all the files matching this pattern in this directory. If we now pipe this to xargs and then give xarg a command, xargs will run this command with those lines as parameters. So this will actually tell us how many lines has each of those files in themselves. If we now sort it in reverse order, treating this as numbers, so not alphabetically but by numerically, we can see what are the largest models in our code base. I really wish this was a joke. It's actually from a project I worked at, not from the start, just to make this clear. This is something I worked with. There was a model with 3,600 lines, and there were 2 others that were over 1,000 lines each. So the other thing is that you might want to check when you join a new project. If you run git log one-line name only, you will see the commit information and then the files that were altered. Then another commit and all the files that were altered. If we grab only the, in this case, Ruby files out of this command, we will see only the Ruby file, but the file will be repeated every time there was a commit that altered it, because it basically means the newest commit altered the first file, the second commit probably the other 2, and so on and so forth. These are just files, one after one, altered by all the subsequent commits. If we now sort this and pipe it to unique-c, unique will tell us how many times a given input string repeats. So we can see that there are actually 63 commits that altered this file, and 183 commits that altered that other file, and only 4 commits that altered this file. And if we again sort it by -r, we can see that there is one particular model that was altered almost 1,100 times. Again, this is actual number. Like this file was changed by almost 1,100 commits, and by now it has been changed by many more. So this is a great way to find what the pain points are in the given code base. Like if there's a file that was altered many times, you probably should take a look at it before you accept to work on that. Let's say we have a migration log. We have a log of all the migrations that we run with RakeDB migrate. If you don't know, it basically says the way database was altered and how much time it took. And let's try to figure out how much time all of the migrations took together. We can grab the line that contains the migration time. This is like this, but we only now want to have the last part. So there are many ways of taking that information out of it, and there are many quick ways, but I usually don't remember any of them. So I usually work my way very painfully, very slowly, but actually step after step getting to where I want to go. So what I can do is I can say every line, treat it as a space-separated columns. So the delimiter should be a space, and I want the 5th column. This leaves me with that. Now I want to drop the S from the end. So I can tell the translate tool that we knew previously not to translate one character to another or a group characters to another, but just to delete all the S characters. Now I have those numbers. If you can see it, just pretend there are just numbers. And now I can pipe it to xargs, which will turn it into a line. And then I can translate all the spaces into pluses. And then I can pipe it to BC, which is this command line calculator. It actually happens much faster in real life, unless you kind of keep messing up the commands. And then we can see this set of migrations took 4 seconds. You can actually do it much faster, and I highly encourage you to check out why this also works. And this is probably how I would do it if I ever remembered the parameters to the paste command, which is very useful. But I knew it's very useful, but I can't remember how it works. So this is why I always end with this cat, tr, and so on pipeline. Okay. 2 more things from these groups, and 3 more things about command line tools. If you ever wanted to compare the output of 2 commands in the past, you probably would run one command, pipe it to a file, run another command, pipe it to a different file, and diff those 2 files together. You can actually run those commands in subshells and redirect their outputs to diff like this, and this will basically show you the difference in the output of running those 2 commands. Very useful when you need it. And the next to last thing is, if you ever created a presentation in tools like PowerPoint or Keynote, you know that you want to have color-coded code examples, like syntax highlighted, but you usually just want to copy them from your editor because you keep working on them in actual text editor. What you can do is you can pb paste, which will, so you can open your editor, copy a code fragment, run pb paste, which would paste that code fragment from the clipboard to the command line. But rather than pasting it on your command line, you can pipe it to pigmentize, which will colorize it with, in this case, assuming it's Ruby syntax and telling it to format is as RTF. you can pipe it back to PB copy, which will copy it back to your clipboard, and then you can paste it into PowerPoint, Keynote, whatever presentation software you use, and suddenly that text fragment will be colorized on its way through this pipeline. Very useful unless you do your presentations in stuff like Reveal.js, where you have all the nice colors that you've been seeing here. The last tool that I want to show you that I actually adore very, very much, Pipe Viewer. If you ever had a large database dump that you wanted to import into a database, if you yell at me that this is a useless use of cat, I agree with you, but I wanted this to be a very simple example. You could actually redirect this file more elegantly to PostgreSQL client, but let's assume you cut a large database dump into your database. And time passes, and you're getting bored. You have no clue what's happening because those things actually don't show up in this game. And you have no clue what's going on. But you can, rather than doing this, you can use Pipe Viewer, which is this little PV command that you put inside of your pipeline, so to speak, and it will pass the input to its output, so it won't alter the things you're cutting, but it will show you how much data is passing through it. So it would tell you, you've been doing this for 12 seconds, it's been 97 megabytes, so it's been 28 megabytes per second. The nice thing, though, is you can actually run Pipe Viewer on the file itself, and it will output the file like cat would do, but it will actually tell you the progress because now it knows the size. So it can tell you, like, it's been 97 megabytes and it will take another 24 seconds. So it's basically eternity till it completes. And we are at 32%. Very useful for all kinds of operations that you have no clue how much time they will take. If you're dumping a database, you're usually out of luck because you don't know how large the dump will be. But if you know that it should be around 600 megabytes, you can queue Pipe Viewer that it should be, just assume the total sum will be 600 megabytes. And then you will get this progress even though the Pipe Viewer itself not necessarily know how large the data will be. And in this case, I was wrong by 8 megabytes, and this dump took 5 minutes to complete. Okay, some other CLI tools that you might find useful: pgrep and pickle for grepping and killing processes by their name rather than their process ID. Watch, which will rerun a command every 2 seconds and show your output. So if you're waiting for a command to change its output, just put a watch before it and it will rerun it times and again. If you ever did this, like rerun it, rerun it, rerun it, this is what computers are made to do. Timeout will time out a command after a given number of minutes, hours, whatever. If you are making a backup and you know it's not supposed to take more than an hour, you can say timeout 1 hour, do the backup, and if it won't finish, timeout will kill it. GNU Parallel is so wonderful that I couldn't give it justice. Just read the documentation. It's not only about running commands in parallel. It's an absolute marvel of engineering. Just read about it. NCDU, if you ever run out of space on your servers, which we never should, but we all do probably, NCDU will show you in Ncourse's text-based interface which files are too big and which directories can be probably get rid of. And proxy local can easily expose any port on your local machine to the outside world. So if you have a local installation of a web application that you want to expose to the client, you can use proxy local and it will give you a domain that is publicly visible. And you can actually name that domain. And this tool is actually free. There are a ton of tools, but this one is actually free and very easy to use. RMadison, if you ever wondered which version of a given package, say PostgreSQL, is in which release of Ubuntu or Debian, RMadison will tell you this. You just go RMadison PostgreSQL and it will show you like that version of Ubuntu had PostgreSQL 9.1, but the other has 9.3. Very useful sometimes. So, to wrap up the talk, this is an alias that you all should have in your bash RC, because rather than saying the boring sudo, you can actually say computer, apt-get install PostgreSQL, computer, reboot, and so on and so forth. There's a wonderful blog post, Git tips from the trenches, a wonderful talk to watch, 5 things you didn't know about PostgreSQL that you really should watch. PostgreSQL awesomeness for Rails developers if you happen to be one. A very nice block of small snippets today I learned about small bytes and bits of code that you can use every day, but so small that you can, and so seldom posted that you can actually internalize them. And there's a CLI Magic Twitter account that posts stuff like this. And this is, I'm sorry you can't see it from the back, but this basically lists all the comments that you have in your bin and user bin directories, shuffles them, takes the first one, so basically a random one, and then displays the man page of that command. You can run this now and then and learn something new about your computer and maybe get frightened, maybe get better, maybe both. So that's almost all I have for you. The last thing that you really should have as aliases are such alias to git, very alias to git, and wow alias to git status, because then you can say, whoa, such commit, very push, and off you go. And that's all I have for you today. Thank you. The slides are at talks.net. Enjoy your lunch.